right, so in this video we're going to be doing question 3 here, B, this second question. We are asked to evaluate the following indefinite integrals. That means go find the general antiderivative. Undifferentiate, if you will. Right? So this is provoking in me, this general antiderivative right here is provoking me in a question. The derivative of what function is cosecant times cotangent plus 1 over the cube root of x to the 5th. And in fact, we are looking for the most general antiderivative. There is a whole family of curves whose derivative is green. All right? So just like when you're taking derivatives of x to a power, I want to go ahead and write that 1 over the cube root of x to the 5th as x to some exponent first, so that when it comes time to undifferentiate, when it comes time to integrate, we'll be able to do power rule in reverse. What was power rule in reverse? In example 1e, we said when the exponent of x is a number other than -1, right? When it's -1, it looks like this got erased. 1 over x is x to the -1 power, right? So when you are integrating, when you are undifferentiating, when you are looking for the general antiderivative of 1 over x, what is that? Oh, that's ln absolute value of x. But when you've got x to a number, an exponent, other than -1, how do we do power rule in reverse? In general, you are always adding 1 to the exponent, x to the n plus 1, and dividing by that new exponent, right? So in preparation for doing that power rule in reverse, I am just going to go ahead and write. I'm not answering the question yet. I am going to write 1 all over the cube root of x to the 5th as x to the -5/3, right? Maybe we do a little bit of scratch for that. 1 over the cube root of x to the 5th. Remember, the denominator is of the fractional exponent is the root that you were taking. This is x to the 5/3 power. And negative exponents are notation for reciprocal. This is x to the -5/3 power. All right. So I have not done any integrating yet. I just did this little bit of algebra and writing this in an equivalent form so I can do power rule in reverse. Now, because I see addition right here, I've got 1, 2 terms, I can compartmentalize my thinking. Just like I can differentiate term by term, I can undifferentiate, I can integrate term by term. So I'm going to first just think about the derivative of what function is cosecant x times cotangent x. And then separately, here's this addition sign. You can even highlight that. I'm going to ask myself the derivative of what function is x to the -5/3. All right, take a second. The derivative of what function is cosecant times cotangent? Well, the derivative of cosecant, there's a little scratch here. If I take the derivative of cosecant x, that's negative cosecant cotangent. There's no negative sign right here. So I want the derivative of a minus cosecant. That'll be minus a minus cosecant times cotangent, which is a positive cosecant times cotangent. Yay! That's what we want here. All right. So this is negative cosecant. And then, again, we're compartmentalizing our thinking because of that addition. One thing plus another. I'm just undifferentiating one of those on its own. We've done that. And now I'm getting ready to differentiate the other term. Integrate the other term. Undifferentiate. I'm going to do power rule in reverse. So to do that, maybe it's worth a little bit of scratch. I've got x to the minus 5/3. Power rule in reverse says we're going to add 1 to that exponent and then divide by that new exponent, right? So I need to know what minus 5/3 plus 1 is. Yeah? Minus 5/3 plus 1. To add anything, you need like terms. So for fractions, we need common denominators. Minus 5/3 plus 1 is minus 2/3. So here I've added 1 to the exponent. My new exponent is going to be x to the minus 2/3. And then we're going to divide by that new exponent. That new exponent here being, I'm running out of color. It's going to have to be yellow. No, how about red? Got a plan for yellow, right? That's where that exponent came from. I promise, I'm trying to go nice and slow, which is tripping me up a little bit, but I promise with a lot of practice, this starts feeling comfortable. But it's almost like when you start trying to think backwards, even thinking forwards can be a little hard. Your brain is going to be a little, I don't know, it's like you're spinning your wheels a little bit for a little bit of time, and just get traction. You will get good at this, I promise. What has Lindsay forgotten besides simplifying this? The plus c. All right, so just cleaning it up, minus cosecant x plus division by minus 2/3 is multiplication by minus 3/2. Plus my c. We've got minus cosecant plus negative 3/2 is just minus 3/2. And I think I'll go ahead and get rid of this negative exponent, or not. I actually think I'm going to leave it. I was going to write x to the 2/3 down here, which is great. Fine. But it is nice when you're looking at it in this form for the check. When you take the derivative of this yellow plus c, do you in fact get green? You sure do. The derivative of minus cosecant is minus a minus cosecant cotangent. It's cosecant cotangent. Check. The derivative of minus 3/2 times x to the minus 2/3 power. We're going to do power rule in reverse, and minus 2/3 times minus 3/2 is minus 6 over minus 6, which is positive 1. X to the minus 2/3 minus 1 is minus 2/3 minus 3/3, which is your minus 5/3. So this is a beautiful place to visually see that we've checked this correctly. Although I feel like this answer just reads a little bit nicer maybe for our reader. All right, here we are, and we are done. And I just went through the check verbally. I'm going to leave the written check to you. Okay? Thank you for watching.